This video is for section 9.1. Our objectives in this section are to evaluate exponential functions, graph exponential functions, evaluate functions with base e, and use compound interest formulas. So we're going to start with example 1. It says the exponential function f of x equals 42.2 times 1.56 to the x power models the average amount spent f of x in dollars at a shopping mall after x hours. What is the average amount spent to the nearest dollar after 4 hours? So this is an exponential function because our variable x is in the exponent, or in the power. And that makes it different from any of the functions that we've seen before. So if x is time in hours, and I want to find the average amount spent after 4 hours, then I plug in 4 for x. And the f of x is going to give me the amount spent. So if I plug in 4 for x, that's 42.2 times 1.56 to the 4th power. Now I have to be careful here when using order of operations. I need to remember that exponents comes before multiplying. So I need to do 1.56 to the 4th power first and then multiply that by 42.2. I can't do 42.2 times 1.56 and then raise the answer to the 4th power. That's not going to work. On many calculators, you can just type it in all at once, like on this calculator. So I'm going to do that. 42.2, and then use the parentheses, just like I have it written there. This A to the B button here is going to give me the option of putting in an exponent. So that's going to be 4. And so my answer here is 249.925658112. Now in the question it says what is the average amount spent to the nearest dollar? So that means I need to round this to the nearest dollar or to the nearest whole number. So the answer that I would need to input here is 250 because 249.9 I would round that up to 250. So this would be $250. You need to pay attention in the problems to how they tell you to round in my math lab, because if you don't round the way that they want you to, then they are going to mark your answer wrong. So 250 is the answer. So next you should look at checkpoint problem number 1. We're using the same function, but now we're finding average amount spent after 3 hours. So do this in your notes, check your answer, and then move on with the rest of the video. Next, we're going to look at graphing exponential functions. So we're going to start with example 2. It says to graph f of x equals 2 to the x power. And the way I'm going to graph this is by making a table of values and plugging in values for x into the function. Remember, f of x is going to give us the y coordinate on the graph. So I'm going to start with -3, plug that in for x. 2 to the -3, the negative exponent flips the 2 to the 3rd to the denominator of a fraction, put 1 in the numerator, and the exponent becomes positive. And that's going to be 1/8. With graphing, it's usually easier to work with decimals than fractions, so I'm going to write the decimal equivalents. You can also get all of these on your calculator. If I plug in -2, I get 1/4. Plugging in -1 gives me 1/2 to the first, which is 1/2, 0.5. Plugging in 0, anything to the 0 power is 1. I'm going to plug in 1, 2 to the first is 2. I'm going to plug in 2, 2 to the second is 4. And I'm going to plug in 3, 2 to the third is 8. So now I'm going to plot these points here. And the graph is going to look like this. So the shape of it kind of has a increased curve, sort of similar to a parabola on one side, but then the other side kind of makes this flat, almost flat line shape. So that's the graph of f of x equals 2 to the x. And what you should do next is look at checkpoint problem number 2. This is f of x equals 3 to the x. For this one, when you make your table, I would just go from -2 to +2. You can see this in the notes that are posted as well, just because putting in bigger numbers makes it kind of hard to graph. So just go from 2 to -2 for this checkpoint, do this in your notes, check your answer in the notes that are posted, and then move on with the rest of the video. Next, we're going to look at example 3. This one is g of x equals 1/2 to the x power. So again, I'm going to graph this by making a table and plugging in values for x. So we're going to start with -3. Now plugging in a negative number here flips the fraction. So it's going to become 2 to the +3, which is 8. Or again, you can get these values by just plugging into your calculator as well. Plugging in -2 gives me 4. Plugging in -1 gives me 2 to the first, which is 2. Plugging in 0, anything to the 0 power is 1. 1/2 to the first power is 1/2, or 0.5. 1/2 squared is 1/4. And lastly, 1/2 to the third is 1/8, or 0.125. So I see similar numbers here that I saw with 2 to the x, but the graph is going to look a little bit different here once I plot these points, because now instead of having the increasing side on the right side, I have it on the left. And so this graph actually goes downward as we go from left to right. And the flat side is on the right side. So what you should do next is checkpoint problem number 3. And again, for this one, when you make your table, you should just go from -2 up through +2. So -2, -1, 0, 1, and 2 when you make your graph. So do this in your notes, check your answer, and then move on with the rest of the video. So what you're going to see in the homework for this section is that the homework problems are going to be fill in the blank and multiple choice. My math lab actually doesn't have the ability to have you make these graphs the way that we made the graphs of lines and parabolas. So the homework problems are going to be, again, multiple choice and fill in the blank because you can't actually make these graphs on my math lab. So we're going to talk about some things here that will help you do the homework. This is characteristics of exponential functions, so looking at in general, if we have the graph of y equals b to the x, where b is positive and not equal to 1. Otherwise, the graph doesn't really work. So one characteristic is that all of these graphs pass through the point 0, 1. Like we saw in the examples and checkpoints, anytime you plug in 0, any number to the 0 power, plug in 0 for a power, the answer is 1. So all of these graphs will pass through that point. If b is greater than 1, then the graph is going to go up as you go from left to right. and greater values of b make the graph steeper. So if I do some quick sketches here, if this is the graph of 2 to the x that we already saw, and then the graph of 3 to the x, if you did this for the checkpoint, you might have noticed it's a little bit steeper than the graph of 2 to the x. So, and if I used a number bigger than 3, then the graph would be even steeper still. So bigger values of b make the graph more steep. If b is between 0 and 1, then as we saw in example 3 and checkpoint 3, the graph is going to go down to the right. And smaller values of b will make the graph steeper. So if I compare the graph of y equals 1/2 to the x and y equals 1/3 to the x, I see that the graph of 1/3 to the x is more steep, and 1/3 is smaller than 1/2. So smaller values of b make steeper graphs. Lastly, we're going to talk about what's called an asymptote at the x-axis. And this graph has an asymptote at the x-axis because it approaches the x-axis but does not cross or touch it. So on that flat side, it's going to get closer and closer to the x-axis, but it never actually reaches it or goes across it. So it approaches but does not cross or touch. The x-axis. So we say that the x-axis is a horizontal asymptote. It's a horizontal asymptote because it's a horizontal line. So the graphs are just going to get closer and closer to the x-axis, but they never actually go across it. So this is some information that should be helpful for some of the homework problems. So now you can go ahead and do the homework assignment for this section.